Okay, for our application of these 4 new shuffles today, as you can see, I have 2 little piles of 8 cards each, and with a mixture of red and black cards in each of them. So what we're going to do actually is we're going to shuffle both of these little packets, okay? And we'll use the new shuffles that we've just learned today, okay? So since this is a packet of 8 and a packet of 8, it makes sense to perform the shuffles that we've been talking about, since all of these shuffles deal with packets of size 8. So there's many ways to proceed here. Now, one way would be to go ahead and have you, the spectator, randomly choose, let's say, 2 of these shuffles to perform on the left-hand pile, and then we'll perform the other 2 shuffles on the right-hand pile. Now, rest assured that we could actually perform more shuffles than just 2 on each of these. In fact, there's many shuffles previously. In fact, the total is 44 now that we could perform on these 2 packets and still finish in the way that we will finish, okay? But to keep the video from getting too long, I thought we would just apply the new shuffles today. Okay, so why don't we begin with the left-hand pile. So which of these 2 shuffles would you like me to perform? It really is a random choice. Now, of course, you're not here, so I'm going to have to just kind of make a random choice myself, but rest assured that if you were here, you truly could choose any 2 of these. So let's say you choose 41 and 44 to perform on the left-hand pile. Okay, so why don't we go ahead, we'll maybe move this one up here. We'll put it at an angle indicating that that one hasn't been shuffled yet. Okay, so shuffle 41 and 44. So 41, what was that? Well, we begin as just an LR shuffle. Remember that? Just left, right. And then we perform a left-right shuffle on each half now. So we go left, right, left, right. And it's going to be kind of tight to fit it in here. Left, right, left, right. And what is the stacking for shuffle 41? Well, it says pile 1 goes on top of pile 2. Those go on top of pile 3. That set of 6 goes on top of pile 4. So if you look at shuffle 41, it's really just saying stack from left to right. Okay, that's just a way to notationally describe that process of stacking from left to right. Okay, so that completes shuffle 41. Now let's do shuffle 44. It begins the same. In fact, all of the ones today begin the same. It's just a left-right shuffle. And then we perform a left-right shuffle on each half. Okay, like that. And the only difference really for today is just the stacking, but stacking makes a big difference to the ending order of any packet. Okay, so shuffle 44, the stacking is as follows. Pile 1 gets stacked on top of pile 3. Pile 2 gets stacked on top of pile 4. And then looking down here at shuffle 44, it says R on L. So the right pile gets stacked on top of the left. Okay, so we have performed shuffle 41 and 44 on that little packet. So maybe we'll switch places here, and we'll indicate now that that one's done. Okay, and then the other 2 shuffles are 42 and 43. And in fact, what order would you like me to do those? You want 43 first? Okay, that's just fine. So we'll do left, right, left, right, left, right. Okay, without sliding all over the place. And then we repeat those actions. Left, right, left, right. Do the same thing for the right-hand pile. Left, right, left, right. And for shuffle 43, what is the stacking? The stacking is pile 1 on top of pile 3. So we're doing kind of this leapfrog stacking, I call it. And then pile 2 leaps over the 3rd pile and lands on top of pile 4. And then it's the left pile on top of the right. Okay, so that completes shuffle 43. And so now we just need to do shuffle 42. Okay, so it begins the same. LR shuffle. and then we perform an LR shuffle on each half. This will give us 4 pairs of cards. And now for shuffle 42, the stacking is from right to left. It says pile 4 goes on top of 3. Those cards go on top of pile 2, and all of those go on top of pile 1. Okay, so we have completed our shuffling of these 2 packets. Okay, and now what we're going to do is, if you were here, I would have you make this choice. We're going to randomly stack these together. Do you want left on right or right on, you want right on left? That's just fine. Okay, and then we're going to mix the cards further, and I really, really wish you were here because you truly can decide how we mix these now, okay? And the choices I will be giving you is we can draw from the top or the bottom, and you can draw from the top and bottom more than once. So for instance, you could do top and then bottom, bottom, top, and maybe top again, and then bottom, then top, top, bottom, bottom, bottom if you like, and then top, top, bottom, top, bottom. Okay, so the choice to take a card from the top or the bottom is truly a free choice. And if you were here, you could have told me exactly how you wanted that done. Okay, now you need to realize that. Okay, so I wasn't doing it in a special way there. It truly is a free choice. Top, bottom, and then you can draw from the top or bottom more than once. Okay, so this gives us a new ordering for the packet. Okay, which is amazing. And now what we're going to do, let me just move this little piece of paper over a little bit here. I'm going to deal out into 8 piles, like so. Try not to go too far off of the camera. Sorry about that. And I realize I just blew it because you could have told me where to put all of these. Sorry about that. You actually can tell me. We're just creating pairs here. So you can deal them out in an orderly fashion if you like, or the spectator can decide where the first level of 8 cards go, and then where the second level of 8 cards go. Okay, that really is a free choice. So sorry, I guess I began dealing them out because I was so concerned about like fitting them. Okay, but just realize that truly is a free choice. The dealing out into 8 piles. You're free to place those cards wherever you want relative to each other, and then the dealing out of the next set of 8 cards onto the 8 that you've just dealt can also be freely chosen by you or the spectator. Okay, and then from here, believe it or not, you can freely decide how we stack these. It's absolutely amazing. So maybe you tell me to pick up this one first, and then maybe this one down here, and then maybe this one over here. Okay, you're freely telling me, okay, that one, this one down here, the top one, okay, the very bottom one, great, and then the final one goes here. That truly, truly was a free choice. You can stack those according to what the spectator asks. Okay, and now all we're going to do to finish is I'm going to dealing out to you first, which is customary or the courteous thing to do. I'm just doing a left-right, but kind of doing it vertically, I guess. Alternately dealing the cards into 2 piles, so we each have 8 cards each. Now, in plain view, the entire time, I have this piece of paper that's been sitting here, and I have a prediction written on that piece of paper. So let's see what I wrote down before we even began any of this. You each have exactly 4 red cards and 4 black cards. How is that even possible? The chances of me guessing this at the beginning is extremely small. Extremely small. Well, let's just see if I even was correct in my prediction. I mean, I could be completely off base here. So I'm claiming that each of us here have 4 red cards and 4 black cards. So let's check it. Okay, there's a red, there's 1, there's a black, another red, there's 2. Oh, there we go, the black, another black, red, red, black. I have 4 red and 4 black. And what about you? Black, red, black, red, black, red, black, red. You have 4 red and 4 black as well. The probability that this would occur by chance alone is extremely low. In fact, it wouldn't take much for the viewer to actually calculate what is the probability that this would happen by chance alone. Okay, so let's go ahead and show you how this was performed. So what I did was, and you can rewind the video and check for yourself, I began with a Bessey sequence for each pile actually, but they'll be the inversion of one another. So I believe I started with a red, black, black, red, black, red, red, black. So if you want to think of red as 1 and black as 0, this would be 1, 0, 0, 1, 0, 1, 1, 0. And then the second pile was an inversion of this relative to color. So I started with black, right? Black, red, red, black, red, black, black, red. Okay? So in the language of zeros and ones, this would be a 0, 1, 1, 0, 1, 0, 0, 1. So currently, they are an inversion of each other. Now, I want to point out something before we turn these face down and begin to shuffle. Our shuffles for today, 3 of these are inversions, right? So shuffles 41, 42, and 43, each of these will, quote, invert a Bessey sequence. What does that mean? That means if we begin with something like this, red, black, black, red, black, red, red, black, and perform shuffle 41 or 42 or 43, we'll get back the inversion, namely, it will be a sequence that begins with black and then red, red, black, red, black, black, red. It'll look like this, right? But, you know, not the same cards, but the color composition will be the same as that one. So 3 of these shuffles, quote, invert Bessey sequences, whereas shuffle 44 does not. Okay? So think about it. If we were to perform shuffle 41 and 42, let's say on this one, well, 41 inverts it so that it has a color composition like this, and then 42 would turn around and invert this back to this kind of arrangement. So performing 2 inversions, they cancel out one another. So you've essentially left the Bessey sequence structure intact. It's the same as it started. So think about the choices that I gave the spectator. I said, okay, we're going to perform any 2 of these shuffles on one of these piles, and then the other 2 shuffles on the other pile. Well, no matter what the spectator chooses, 2 inversions will be chosen together because there's 3 of them and only 1 that does not invert the sequence. So if you perform 2 inversions, let's say on this one, you leave it the way it is relative to color composition. Whereas if you now perform the remaining shuffles, which will consist of 1 inversion and 1 non-inversion, which is 44, then it will invert the sequence from its current state. So here, this inverted would now give us a packet structure where we begin with a red, black, black, red, black, red, red, black. So once we've done that, if we do 2 inversions here, we leave the colors as they are. If we do 1 inversion here, we invert it so that we start with a red at the top. what will happen is these two organizations of the colors will be identical. They'll both have a red and then black, black, red, black, red, red, black. Okay? So maybe you might have to give that a little bit of thought, but any two that they choose, if they happen to both be inversions, they leave the structure as it was relative to color organization, and then performing the remaining two shuffles, one is guaranteed to be an inversion and the other one's not, namely 44. Okay? So the point is, let me just write this out over here on my piece of paper, on my prediction here. So what will happen then is after we perform, now we don't know for sure which of these two piles will be inverted. We just know one of them will be inverted, bringing them to the same color organization as the other. That's the key. So let's say this one is the one that gets inverted. So what I would have it on the left is I would have red, black, black, red, black, red, red, black. Okay, that would be returned to that kind of color organization. And then if this is the inverted pile, it will change from what it is, namely black, red, red, black, and so forth, to the same as the left-hand pile. So it'll be red, black, black, red, black, red, red, black. Okay, so the key is we'll get exactly the same pattern of colors for each of these two piles. They'll be identical. Well, what does that mean if we randomly stack these together, which is what we'll be doing in just a minute or two? Well, we're looking at a cyclic construction in which there's a pattern, namely all of this, that repeats twice. Okay? So if you have watched any of my videos on the Gilbreth principle, if you have a cyclic construction, the Gilbreth principle applies as long as you perform a Gilbreth shuffle. Okay, and that's that shuffle where I said they are free to take from the top or the bottom and take from the top or bottom repeatedly as well. Okay, so I'm just trying to give you a glimpse as to where we're going so that when we get to the different stages, I can remind you of some of these explanations that I gave to kind of fill in any gaps that might be there. Now, if you've never used the Gilbreth principle, you may want to look at some of the videos on the Hidden Structures channel that talk about the Gilbreth principle. Very powerful principle. You can do some amazing mathematical card magic with the Gilbreth principle. But this will be a simple application of the Gilbreth principle. Okay? So the key is after we do the mixing that's asked for by the spectator, we're looking at identical color compositions for each pile, and then if you stack those in either order, we have a repeating pattern. It repeats twice. That technically is a cyclic construction, and then the Gilbreth principle and its conclusion will be in force. Okay, and I guess why don't I go ahead and just kind of give you a peek at what the conclusion is for the Gilbreth principle. If these two piles of cards are stacked together and then, quote, Gilbreth shuffled, and we'll kind of show you how that's done. What that will mean then is that the top 8 cards after that Gilbreth shuffle will consist of exactly 4 red and 4 black in some order. We won't know the order. And the bottom 8 of that Gilbreth shuffle packet will consist of exactly 4 red and 4 black cards in some order. And we won't know the precise order. Okay, so why don't we get to that stage and then I'll kind of continue on with some explanation. So this is where I started. So if you actually just, now the key here is if you're not able to follow all of the mathematics, that's understandable, especially if you haven't watched some of these other videos on the Hidden Structures channel. But setting that aside, if you actually just follow these steps, it's guaranteed to work for you, and your prediction is guaranteed to be correct. Okay, so don't lose heart because of maybe not being able to fill in all of the gaps yourself. So just begin with these 2 Bessey Sequences. This is like 1001, 0110, and it's inversion. Okay, so now we set those down like that, and then we give the spectator the freedom to choose either to any two of these new shuffles to perform. Okay, and so maybe we'll choose something different this time. So let's say, okay, we'll put this one up here. This one's not shuffled yet. Okay, so we're going to shuffle this packet first. And so maybe the spectator asks for 41 and 43. Okay, this time. Okay, so what is 41? 41 is the repeat LR. Okay, so you just go through and do the repeat LR. Okay, so we're looking at 41. Okay, and then you just do left, right, and then left, right. Whoops, going off the screen. And then for 41, what's the stacking? Oh, it's just from left to right. Okay, very good. Okay, that completes shuffle 41. Now shuffle 43, it begins the same. All of these actually begin the same. Okay, and then we're going to do deal out left, right, so that we get 4 pairs of cards. And then for shuffle 43, what's the stacking? Oh, it's a leapfrog. We're going to take pile 1, leap over pile 2, land on top of pile 3. 2 leaps over its neighbor and lands on top of pile 4. And then we're stacking left on right. Okay, so we have performed shuffle 41 and 43 on this little packet of 8s. We'll come over here. That one's done. And then the agreement was we'll perform whatever shuffles remain in our list of 4 shuffles here. So why don't we do 42 next? So this would be left, right. Very good. And then we'll do left, right again. Left, right again. And then for 42, oh, it's stacking from right to left. Okay, so that's not too difficult. Okay, and then 44. What's 44? It's just an LR. Okay, and then we deal those into each half into 2. And then 44, the stacking now is this leapfrog stacking 1 on 3, 2 on 4, but this time it's the right pile on top of the left. Okay, so we have now shuffled each pile of 8 twice using 2 shuffles randomly chosen by the spectator. Okay, now from what I was saying over here, you remember what I was talking about here? See which one, see if you can anticipate which one has not been inverted, which pile. Now come to think of it, I don't remember how I pulled these from the top, but the point is one of these will be inverted from what it was and the other one won't be. Okay, so for example, okay, this one has a top of black, so this one better have a top card of black as well, which it does. Okay, so right now this will be an invert. So we have black, red, black. Very good. And then red, black, red. And we'll get the same organization here. They'll truly be identical. Black, red, black, red, black, red. Okay, so these are exactly the same. It ends up that it's the inversion of these, where we just start with black instead of red. But they're identical. Okay, identical pattern. So if we stack these in either order, this becomes a cyclic construction. And it has cycle length 8. So there's a pattern of cards, of 8 cards that repeats twice. Okay. Now the Gilbreth principle says the following: if you perform a Gilbreth shuffle, something important will happen regarding the ending structure. Okay. Now, the traditional way to perform a Gilbert shuffle is to deal out a certain number of cards until the spectator tells you stop, and then you just riffle shuffle those two packets together. That is the classic Gilbert shuffle, which works great if you want to do that. An in-hand Gilbert shuffle, in some ways, I think is more powerful because it's giving the spectator so many choices. Okay, so this is where I said, okay, we can draw from the top or from the bottom, sit down on the table and build up and rearrange the cards according to those choices, and then just know that you can draw from the top or bottom more than once. So you could do like top, top, and then bottom, and then top, and then you could do bottom 3 times if you wanted, and then you could do top, and then a bottom, then top, a couple from the bottom, and then 1 from the top, 1 from the bottom, and then 2 from the top. Okay, so all of those choices are absolutely free choices that can be made by anyone, and in particular by the spectator. And believe it or not, that kind of mixing is equivalent to dealing out a certain number of cards and then riffle shuffling those together. Okay, so this has been Gilbert shuffled. Okay, well, the conclusion there regarding the kind of structure this has after a Gilbert shuffle is that the top 8 cards will consist of the same color cards as we had here as far as the quantity. So we had 4 red, 4 black, 4 red, 4 black in some order, right? So the Gilbert's principle tells us that the top 8 will still consist of 4 red and 4 black in some order. We don't care about the order. The bottom half will consist of 4 red and 4 black in some order. Okay, so that's the conclusion of the Gilbert's principle. The Gilbert principle guarantees that that will happen. Well, think about it. If the top 8 cards here are such that within those 8, you have 4 red and 4 black in some order. If I deal these out into, in fact, we can even do it this way, deal them out into 8 piles in some order. In fact, let me just show you that these can be set down anywhere. And then so right now what I know is among these 8 cards, somewhere there are 4 red and 4 black. I know that for sure. In fact, let's just confirm that to kind of, strengthen your faith. I don't even know where they are. I just know that there's 4 red and 4 black in here somewhere. Okay, there we go. No idea where. Okay, now I do. So 1 red, 2, 3, 4 reds, 1, 2, 3, 4 blacks. Okay, and the Gilbert principle guarantees that that would happen. Okay, so think about it. So on level 1 of these 8 piles, I have 8 cards where 4 of them are red and 4 are black. Okay, and that means there's 4 red and 4 black in the remaining 8. Okay, so now I'm free to put these anywhere. That's the key. Okay, so I'm going to build up, I need to build up a second level on all of them. That's the only restriction, so I can go like that. And so now what I know about the second level is on the second level, there will be 4 red and 4 black in some order. Okay? Now we know that to be true here by elimination because we actually started with 8 red and 8 black. But okay, now think about it. So on level 1, there's 4 red and 4 black. On level 2, there's 4 red and 4 black. So what's going to happen if I just randomly stack these? And keep in mind how we're going to finish. Once I have randomly stacked these, I'm going to then turn around and alternately deal 1 to the spectator, 1 to myself, 1 to the spectator, 1 to myself. Okay, so let's focus on the bottom cards. Okay, which I've shown you. I've shown you that the bottom cards consist of 4 red and 4 black. Well, think about that. As I pick this up, I know that the bottom card is from a set of bottom cards where 4 are red and 4 are black. Okay, so if I now set this on top, of, let's say, this one right here. So think about it. So if this is going to be the top of the packet, you can stack them however you want. But let's go ahead and we'll stack like this. So if you focus on the second card, the card in position 2 came from level 1, right? Now if I stack it on top of these two, the card now in position 4 came from level 1. So right here, this came from level 1, this came from level 1. They're coming from the same level. So when I stack all of these, all of the even position cards will be from level 1, and all of the odd position cards will be from level 2. Okay? So it doesn't actually matter how you stack these, because we're going to turn around. Oh, I guess I changed how I stacked them. Sorry about that. But you can stack them in any order. You can put this in the bottom and top or whatever. But what will always be true about the cards that began in level 1, they will all be in the even positions of this packet, and the complementary conclusion is true for level 2. And so what that means then is if I now begin to deal like, so think about it. So like if this, if this is level 2 and level 1, right? So this is like level 2, 1, level 2, 1, level 2, level 1, level 2, level 1, level 2, 1, 2, 1, 2, 1, 2, 1. All of these came from the same original level of those 8 piles, and the same thing here. Well, we already know that at each level, the cards are made up of exactly 4 red and 4 black in some order. So at this point, you can bring out your prediction because you know it's going to be true that each of you will have exactly 4 red and 4 black, and then you can just reveal that, okay? Even though we don't know exactly, where the red and blacks are, okay? There's a red, there's a red, there's a red, there's red, there we go, and then a black. So we have 4 red and 4 black, and of course the same thing will be true here, right? Okay, so I realize that that's a pretty subtle mathematical routine to understand fully, but the mechanics really aren't too bad. So thank you for watching, and take a look at the other videos on the Hidden Structures channel, and in particular the ones that deal with Bessey shuffle diagrams. We have one more video in this series, video 12, and within that video I will show you something called a non-example, because all of the shuffles I've been showing you are, quote, Bessey shuffles, and they're Bessey shuffles because they either preserve or invert Bessey sequences, okay? So I'm going to show you one in particular where this doesn't work. It's not a Bessey shuffle, and it deals with the Australian under-down shuffle. Not the down-under. That one works great, but the Australian under-down doesn't quite preserve or invert Bessey sequences. And so I'll clearly show you that in our 12th and final video in this series. So thank you for watching.